This video will not only show the answers to the difficult dimensional analysis questions 4 and 5, but it will also show you how to work through the problems. Problem number 4 on the difficult dimensional analysis worksheet reads, exactly 1 mole of oxygen gas is equal to 32.00 grams of oxygen gas. If this building contains 2.78 kilograms of oxygen gas, how many moles are in the building? So in order to solve this problem, you need to look for conversion factors, you need to look for a known, and you need to look for an unknown. Alright, the conversion factor, if you reread the first sentence gives you a conversion factor which might be useful in solving the problem. 1 mole of oxygen gas is equal to 32.00 grams of oxygen gas. The known is what's any other information that you know in this problem. Well, the other information that you know that's numerical information is that you start with 2.78 kilograms of oxygen gas. And then your unknown is what you're looking for. So if you read the question, it says right in the question how many moles are in the building. So you're looking for how many moles of oxygen gas are in the building. So your unknown is moles of oxygen. In any dimensional analysis problem, the known always comes first. So we're going to write the known first. 2.78 kilograms of oxygen gas. It's followed by any conversion factors that might be useful. Well, right now we have kilograms of oxygen gas, and the only conversion factor that we have has the units moles and grams in it. There's no conversion factor with kilograms. So how do we solve this problem? Well, we have to make a conversion factor with kilograms in it. So what do we know about kilograms that's related to either moles or grams? Well, we know that 1 kilogram is equal to 1,000 grams. So that might be useful in solving this problem. So we're going to go back to where we were doing a dimensional analysis and use that conversion factor. So you look at your known 2.78 kilograms of oxygen gas, and you're now going to multiply it by the conversion factor that we just wrote. And we have to put kilograms on the bottom. So we put kilograms of oxygen gas on the bottom, and the other unit that we have is grams of oxygen gas on top. What number goes next to kilograms? Well, you look at the conversion factor. 1 kilogram is equal to 1,000 grams. So 1,000 goes on top and 1 goes on the bottom. Units cancel, so you cancel kilograms of oxygen gas. And now if you solve the problem right now, you just get grams of oxygen gas for your final answer. But we want to find moles of oxygen gas, so you multiply it by another conversion factor. And the other conversion factor, which we have, we're going to put grams of oxygen on the bottom, and you'll put moles of oxygen on top. And the grams is 32.00 grams. I get that from the conversion factor. And on top, the number is going to be 1 mole. Now, the units grams are going to cancel, and you're left with just moles. What are you trying to solve for? Moles of oxygen gas. So now we're in good shape. In your calculator, now you want to multiply, or if you start off with 2.78 kilograms of oxygen, you multiply it by the numerator 1,000, and then you divide it by 1, so you always divide the denominators. You multiply that answer, which is 2,780, by 1 in the numerator, gives you the same answer, and then you divide it by 32. Your final answer comes out to be 86.875 moles. Well, this is not exactly correct because you need to look back and figure out how many significant figures are you going to use to answer this. And if you look back at the original known had 3 significant figures. So the only other thing that was measured was this, which was 32 grams of oxygen, 32.00 grams of oxygen in 1 mole. So you're going to have to round this, since this is 3 significant figures, your final answer has to be to 3 significant figures. So you're going to round this to 86.8, but this 7 rounds the 8 up, so the final answer will be 86.9 moles of oxygen gas. In problem 5, you have to convert 7.86 grams per centimeter squared to milligrams per square millimeter. So we got to find out what's our known, our unknown, and our conversion factors to solve this problem. Whenever you only see one number in a problem, that is your known. So the known in this problem is 7.86 grams per centimeter squared. Our unknown is what we're looking for, so we're trying to convert this to milligrams per square millimeter. So for our unknown, I'm going to write, we're trying to find milligrams per square millimeter. This problem gives us 0 conversion factors, so we need to figure out the conversion factors on our own. So in the known, you can see you have grams, and the unknown, you have milligrams. So how are you going to convert grams to milligrams? Well, you should know that milli means 1,000. So for every 1 gram, that's equal to 1,000 milligrams. So that you can use as one conversion factor to try to get from your known to your unknown. The other thing we're going to have to try to get to is from centimeters squared to millimeters squared. Well, you might not know anything about centimeters squared to millimeters squared, but you do know something about centimeters to millimeters. You should know that for every 1 meter, that's equal to 100 centimeters, and for every 1 meter, that's equal to 1,000 millimeters. So with that information, you should be able to convert centimeters to meters and meters to millimeters, except the only problem is that they're not squared. So what you have to do is square both of those conversion factors. So if you square this side of this conversion factor and you square the other side of the conversion factor, well, 1 times 1 is 1. And meters, you also have to square that unit, so it's going to be 1 meter squared. In this other side, if you square this whole other side, 100 times 100, well, that gives you 10,000. And centimeters also gets squared. We're going to have to do the same thing to this other conversion factor. We'll square this side and square this side. So we have 1 meter squared is equal to, and then when you square this side, 1,000 squared gives you 1 with 6 zeros after it, and then that's going to be millimeters squared. So now we have conversion factors that are squared. So now if we look at the problem, we can go from grams to milligrams, and we can also go from centimeters squared, right, to meters squared, and meters squared to millimeters squared, which that's what we're trying to get to, is millimeters squared. Okay, so how do we start this problem? We always start the dimensional analysis part of the problem with the known. So I'm going to write down the known first. I write it down 7.86 grams per every 1 centimeter squared, because that's what this number means. Now, I'm going to multiply the known by something that will cancel one of these units, either cancel grams or centimeters squared. Well, I'm going to use the one that cancels grams. I'm going to use this first conversion factor up here. So I'm going to put grams on the bottom and milligrams on top. The numbers that correspond with this conversion factor is 1 gram and 1,000 milligrams. At this point, grams cancel, and you're left with milligrams and centimeters squared. Well, in our final answer, we want milligrams, but we don't want centimeters squared, so we got to get rid of that centimeters squared. So I'm going to multiply by another conversion factor that has centimeters squared, which is this one. So we're going to multiply it centimeters squared has to be on top in order for these two units to cancel. So on top I'm going to put 10,000 centimeters squared over 1 meter squared. And now centimeters squared cancels. Now, how do we get from meters squared to millimeters squared? That's what we're looking for, is millimeters squared. We multiply by this other conversion factor. We put meters squared on top, and we put millimeters squared on the bottom. Alright, why do we do that? So meters squared cancels, and our final units, the only units that we have left, are milligrams and millimeters squared. So our final answer will be in milligrams per millimeters squared, and we need to take 7.86 times 1,000 times 10,000 divided by a million, and then we get our final answer, which comes out to be 78.6 milligrams per millimeter squared.